Good morning. My name is Jacques Raphael. I'm a professor of economics, finance, and econometrics. I own a private college in Athens, and through this channel, which is called Economic Experts, you will be able to watch several videos referring related to the fields of econometrics, economics, finance, accounting, statistics, etc. Today we are going to demonstrate how the per sample t-test is performed in the SPSS program. In this case, we want to see whether the mean of a group has changed over time. In our case, we have selected a group of 25 swimmers where we have marked their performance in 100-meter freestyle. And we want to see, after the implementation of a new training method, if the mean has changed over time, let's say in a 1 year time frame. So here we can watch the swimming times before the new training method has been implemented. Here the first swimmer has performed 56 seconds in 100-meter freestyle. And after the new method, we have wrote down his performance again, and we can see that it has improved to 55 seconds in 100-meter freestyle. That's why we name this sample after. These two samples, before and after, are dependent since they are referring to the same group. That's why it is a paired sample t-test. Let's see how we are going to perform now this test to see if the mean has changed over time, and to see also if there has been a statistically improvement in the swimming performance after the new training method. We should point out the fact that we want to draw conclusions regarding the entire population with regard always to this new training method. And to draw these conclusions, we collected randomly a sample of 25 swimmers. Now let's see how this test is performed. We put analyze, we press analyze, then compare means, and then per sample t-test. We press this button. Before we put it in variable 1, after in variable 2, and we press the button OK. First of all, we can see that the swimming performance after 1 year with the implementation of the new training method has improved. It has dropped from 59.48 seconds to, as I can see here, 57.28 seconds. We can see so that there has been a decrease in times in the average mean in the average swimming time after the implementation of the new training method, which lasted for 1 year. So here we can see that there is an improvement in the swimming time of the one in the event of 100 meters freestyle, and these are seconds. The random variable referring to this group is expressed in seconds. Now let's see whether the difference between before and after is statistically significant. The null hypothesis is before minus after is equal to 0, and the alternative hypothesis, since it is a two-tailed test, is before minus after is different from 0. We can see that the p-value of the t-test is smaller than the level of significance. It's the p-value is equal to 0, which is obviously smaller than the 0.05 level of significance. This means that the difference of means before minus after is statistically significant. This means, therefore, that there has been a change in the average mean of the swimming times after the implementation of the new training method, and this this change has been statistically significant. Therefore, the new training method was effective, since not only did it improve the swimming time of the swimmers competing in the 100 meters freestyle, but this change of means is statistically significant, since the difference before minus after is statistically significant. We can see that if we take the confidence interval with 95% probability, in all the cases, the before minus after difference is bigger than 0, which means that with 95% probability, the average mean will be lower than the average mean after the new training method will be lower than the average mean before the new training method. So there has been there has been an improvement in the performance. And since the difference of means is statistically significant due to the 0 p-value, this improvement of swimming times after the new training method is statistically significant. So this is how we carry out the per sample t-test. Let's make a small repetition. We write down the performance uh, after selecting the group of 25 swimmers before the new training method. We write down the performance after the new training method. We carry out the sample t-test to see if the change of means has been statistically significant. Since the difference is statistically significant, the mean of the change of the average swimming time after the new training method has been statistically significant. And additionally, since the difference before minus after is bigger than 0, uh, and we show that in the confidence interval, the change was not only statistically significant after the new training method, but also there has been an improvement in the performance, since now the average mean is always lower than the average mean after the new training method is lower than the average mean before the new training method. We can see this in the confidence interval, which says before minus after, with 95% probability. Thank you very much. My name is Zach Raphael. Stay tuned to this channel. We shall be uploading very other interesting videos regarding economics, econometrics, statistics, finance, etc. Thank you very much.